Let us learn some easy steps to sketch sine function. I have taken a simple problem. It's kind of tricky, but it's very simple. Sketch y equals to sine of half x plus 15 degrees. Now, whenever you have this kind of a function, remember to factor half. That is the first part. So let me factor and rewrite this equation. Y equals to sine half, and then we get x. When you factor out half, you get 30 degrees there, right? So plus 30. So that is the function which you really want to sketch. It is important to factor so that you can see that horizontal translation is 30 units to left, 30 degrees to left, right? So first let's understand what the transformations are. There are two transformations, both are horizontal. One is affecting the time period, which is there is half wave in 360. So one is time period. So we'll say horizontally it is stretch by factor of 2, right? That really means that the time period of this function becomes 360 into 2. So let me write down that also. That is time period equals to 360 times 2, which is equal to 720 degrees, right? So that is the effect of half here. And second one is there is a horizontal translation 30 units left. It's 30 degrees left. This basically is a phase shift, right? Of minus 30 degrees. So sine function will start 30 degrees earlier. So these are the two basic transformations which we can see from the given function. Now to sketch the function, we can adopt a couple of methods. So I'll discuss two methods with you. One is the points. So that is, if you have a sine function, basically, then for different values of x, what are the values of sine x? Let's see that. If x is 0, sine x is 0. This is x in degrees. If x is 90 degrees, then sine x is 1. If it is 180 degrees, then it is 0. And 270 degrees gives you minus 1. 360 degrees is back to 0, right? So that is basic sine function. Now when you transform, so in this particular case, what is happening? In this particular case, the transformation really affects x values, not the y values, right? Now your function here is sine of, let me write half x plus 30. Now, the y values are not getting affected. There is no vertical stretch, compression, reflection, or translation. As far as the x values are concerned, it affects the time period. So it is times 2, the x value, and then minus 30. So that is the effect on x value. So what is happening to x values really is that to calculate x values, we need to do times 2 of this, right? So it is 2 times original x values. Let me write this as x0, and then take away 30 from there to get the x values. As far as the y values are concerned, they remain the same, right? So the transformed values, let me now show you here how well the transformed values will be, right? So 2 times 0 is 0, minus 30 will give me minus 30 degrees, and we'll have 0 here. 90 times 2 is 180. 180 minus 30 will give us 150, right? We can use calculator also. So it is 150 degrees. 2 times 180 is 360. 360 minus 30 will give you 330 degrees. 270 times 2 is 540. 540 take away 30 is 510 degrees. and 360 times 2 is 720. 720 take away 30 will be 690 degrees. So basically what is going to happen is our 0, 1 values are going to get translated. They are going to shift horizontally. So the values at these points will be 1, 0, minus 1 and 0, right? That is what will really happen. So basically our sine function will start at minus 30 and at 690. So that is the kind of transformation. These are your image points of the original points, right? So that is how you're going to see it. Now let me sketch this. So I'll make a kind of rough sketch. So let's say this is our coordinate axis, right? Now here it is. So basically what we see here is that the sine function gets transformed. It starts at minus 30 because of this, right? And it moves. So that means if this is 0 and let's say this is minus 30, it starts like that, right? Minus 30. So let me make a scale and then I'll show you how it should look like. So basically the sine function originally, let us say, is kind of like this. Now what really happens is it gets stretched, right? So that means every point gets horizontally stretched by a factor of 2. So instead of ending here, the function really ends here, right? So that is the first. Maximum, which is at 90, moves to 180, right? This maximum moves to 180. And 180 position moves to 360. So this moves at this point, right? That is where, and this point 180 moves to 360. So that is the second movement. This is first. 90 plus 90, 180 plus 180, and this place moves to 270. So twice the distance, right? And finally 360 moves to 720, right? 0 remains at 0 because 0 times anything is 0, right? So we get our first function, first transformation, which is horizontal stretch. So it should be like this, right? So we can continue this and join these points, right? So that is how we will get basically sine of half x. So this is sine of half x, right? Earlier what we had drawn was sine x. Now what we need to do is shift it 30 units to left. So if let us say this is 360, this much is 180, this is 90. So 30 is kind of small, right? Like this. So we are making the small unit as 30 for us. So all these points are going to move left by 30 units. Do you see that? So these points will be kind of left. Do you see that? So now we can join these points to get our, so this was maximum here, so this maximum will move to this place. So we have a function like this, correct? So that will be our final sine function, which is sine of half x plus 30 degrees. So as expected, the sine function started from minus 30 and it ended at 690. Do you see that? So that is how you could draw sine of half x plus 30 in steps. Now another way to do it was like, why these are the easy steps to follow, right? Now you could have got this answer straight away, kind of like this also, which is like, so here is another solution to the same thing. So we are basically drawing a sine function. So sine function looks like this, correct? So that is a sine function. So in our sine function, we know it is starting at minus 30, right? So that is our axis of symmetry. Since it is starting at minus 30, since that is a phase shift, Let's start with minus 30. Now the time period is 720, right? So let us add 720 to minus 30. If you add 720 to minus 30, you will get 690. So that point becomes 690 for you, correct? Since there is no change in amplitude, it is 1, so that will be corresponding to plus 1, and this will be corresponding to minus 1, correct? So you can draw your axis later, that is like this, right? Going through 0, right? And that is your x-axis. So you could have drawn straight away your function directly, also knowing fully well the two parameters. One is phase shift starting at minus 30. Second is the time period of 720. So it starts minus 30, add 720, and you get your function straight. So that is another way of doing the same thing, right? So that is, follow the method which you like. But here what we have shown you is, if you are given an equation like this, factor this number, otherwise you'll get wrong phase shift. After factoring, write down what are the transformations. Two critical transformations, rather only two transformations which we see here, are phase shift and time period. Write them down. You could always refer to the original points and their image points, right? And sketch your graph, final graph. Or you could follow step by step, as we shown here, right? These are steps of transformation, right? Let me write down here. Steps of transformation. So we did multiplication, which is horizontally stretched, and then translation of 30 degrees to left. Two steps, you get your final function. And this is from the straight knowledge which you gain, that your function is sinusoidal, maximum is 1, minimum is minus 1, and time period is 720. So you get this wave. So that is, these are different ways of drawing the same function. I hope you get the concept. Share with your friends, and if you like it, do give a thumbs up. Thank you. Bye. I hope you appreciate it. Thank you, and all the best.